All right. Good evening, everybody. I welcome you all to the 11th week of live interaction sessions for the course Bioinformatics, Algorithms and Applications. So, before I start, I see a message from Kritika. So, there's the online calculator which you cannot use for solving three equations. So, I don't know whether such questions might be given in the first place, or it'll be solvable by using a trial and error method probably. um, I haven't looked into the link for the online calculator, but I believe it should be as good as the normal online calculators that we use for gate exams or such, right? But I can get back to you on this. So maybe I'll copy this question and take it up with the NPTEL or bioinformatics team, which actually handles the exam or setting the question papers or evaluating things. So I'll just print the screen and save it so I can take this up with the team. Meanwhile, so I'm going to share the screen for today's presentation. Please let me know if the screen is visible. I mean, you understand the concept of solving those equations, right? So that's all that matters. Regarding the solving with online calculators, I'll get back to you on this. It's better that I use the next session to announce this particular information. So, can you all see my screen? And I hope I'm audible as well. Okay, so this week we are looking into topics for week 11 containing demo for Autodoc and awk programming parts 1 and 2 and development of algorithms parts 1 and 2. There's an error in it in this area. I will anyway. So let's start with the first question. What is FNR in awk? I don't think this was covered in the lectures, but you can take a guess or attempt at answering this question. Option A, FNR is the current record number in the current file. FNR is the number of fields in the current input record. FNR is an array containing the value of environment. And D, none of the above. That's right, Kritika. So, thank you, Devangana. We have two votes, one each for A and B. Anybody else? Nagamani agrees with Devangana. Anybody else? Any other answers? I will just confirm that the screen is getting recorded, because last time it so happened that the screen was not recording. Okay, shall we see the answer then? So option A is the right answer. FNR refers to the record number, typically the line number, in the current file. Excuse the issue with my pen. Alright, so in the current file, the record number in the current file. That's the F here. So there's another explanation here. Are two inbuilt awk functions where NR tells us the total number of records that we have read so far, while FNR gives us the number of records we have read in the current input file. So option A is right. FNR is the number of fields in a current input record is wrong. And is an array containing the value of environment is wrong, and none of the above is also. Question 2. Which of the following is a built-in variable for awk? One vote for C from Devangana. Anybody else? Okay, so okay, Kritika also says FS. So P, S, and F, N are wrong, but $0 takes the entire line into account, right? None of the fields, the entire all the fields of a particular line. So entire input record, as well as FS, which is the field separator space. So both B and C are answers, correct answers for the question 2. Question 3. False negative means option A, experiment was positive and predicted positive. Experiment was negative and predicted negative. Experiment was positive but predicted negative. And D, experiment was negative but predicted positive. Devangana says C. Amardeep also says C. Thus, thank you, Malini. Thank you, Kritika. So everybody's clear, right? Thank you, Nagaman. Good to see you all participate. So 5 votes unanimously for option C. So when we say false negative, false or true is from the point of view of prediction, right? So when a prediction is false, which means experimentally it was something else and prediction was different from it. So false negative meaning predicted value was negative but experiment was true, which means it is actually positive. So experimentally positive are your shortlisted options. And if prediction is positive, then it's a true positive, right? So this is wrong and the other one is right. Clear? So experiment positive and predicted positive will be true positive. Experiment negative but predicted negative will be true negative. This will be false negative. And experiment was negative but predicted positive will be false positive. So we're all in the same page hopefully on these, or otherwise now you can refresh this because this will be useful for you in the forthcoming questions. Great. So question 4, dash generally happens when the gap between the training and the test error is large. Option A, good fitting. B, overfitting. C, underfitting. And D, all of the above. Rohini has answered C. Any other answers? So unfortunately, I did not attach a material for this in order to justify. So in the gap between the training and test error is large. Definitely, it's not good fitting, and therefore that eliminates all of the above. So between overfitting and underfitting, why would you choose C and not B? So remember the case when it was discussed in the lectures where you have too many features mapped or correlated into the same data set, or you have very little data for the number of less than 5 times. If you have, say, uh, to quote the exact example that was discussed, 15 features in a data set of 30 data, that's like oddly giving you on an average just two um, features, two data per feature, right? So it has to be at least 75 or more. So what happens in such a case when you have a new test which is not fitting into the model that has been generated with this small data set covering so many features, the error will be huge, and this is a case of overfitting. But I understand that this verbal explanation might not be enough for you to grasp onto. So this is another question that I want to repeat or take up next week. I hope I had not left questions like this before, where I mean sometimes I tell you that I'll add some material in the PPTs and upload, so I've been doing that. Apart from that, last time we had this jackknife test where I said I will confirm and get back to you. So my explanation was right, where again if you had seen this week's lectures, it would be this n minus 1 uh, data set. I mean, out of n data points, you use n minus 1 to train and the remaining one as the test and repeat it n times. So this is a type of jackknife uh, testing. All right. So similarly, I hope I had not left any other questions previously. So two things: one, the calculator issue for three equations, so that I should discuss as I begin the next session, next week's session. So please remind me if I forget. And apart from that, I want to add material either on the PPT or take this question up again. But the answer is B. I'm sad to see none of you attempted or guessed B. All right. Question 5. Feature selection is important for option A, identifying the important properties. Option B, gaining insights into the underlying mechanisms. Option C, developing a reliable prediction method. And option D, all of the above. So for people who missed to attend last week's session, only my audio got recorded, so I had to redo solving of the same assignment in a quicker sense, and I've uploaded it. So this jackknife n minus one question that I discussed now was with respect to that week. Thank you, Devangana and Amardeep and Nagamani. Anybody else? think it's a straightforward question, right? Just waiting for more participation. Feature selection is important, definitely, for identifying the important properties, gaining insights into the underlying mechanisms, and developing a reliable prediction method. So, option D is right. Question 6. For the following assignment, where B is positive, what is the specificity? So, I have not solved this a priori, so I will be solving with you or based on the answers that you are going to give me. So, Devangana says C. Anybody else? So, we have three such questions in total, I think, for today. First, what are the. Okay, I'll wait for another 1 or 2 minutes for people to answer, then we'll go about solving the question. Anybody else? Answers? Okay, now we'll look into that. All right. Oh, Devangana also gets 50. That's weird. Okay. What about Amardeep? Do you get 57 or 50? Yes for. All right, others. First, let's write out what these values are. Okay. What are the true positives here? Where both experimental and predicted values say positive. So B is for positive, N is for negative here. So the green ones here are true positives. 1, 2, 3, 4, 5. So number of true positives are 5. True negatives where experimental and predicted values are negative. So you have 1, 2, 3, 4. All the yellow ones are true negatives. The third case is false positive. False because your predicted says positive but experimental is negative. Wherever you have combination of experimental being N and predicted being P, those are your false positives. So this is 1 and 2, 3. Is that right? And false negative is when your prediction is negative but it's false because experimental is positive. So you have 1 and 2, here 3, and one more 4. I'm just putting arrows here so that you can differentiate. Now what is specificity? Please excuse my poor writing. Thank you, Kritika. Specificity is total negative divided by total, sorry, true negatives divided by true negatives plus false positives, because false positives are truly negative, right? Truly in the sense they are experimentally negative, so all the negatives put together in the denominator and true negatives in the numerator. So what will that be? Tn is equal to 4 divided by Tn plus Fp. So I messed up in the way I spoke here. Specificity will be the true negatives divided by all negatives, which will be true negatives plus false positives. Right? So that is 4 by 7, which is 0.5714. In percentage, that will be 57.14. Nagamani and Debangana, was it fine now? I don't know how or what values you calculated for these four parameters. So in case you have made a mistake in this, maybe your ratio would have come up different. Okay, that's all right. Option C is right. Question 7. Which character is used to identify the fields or columns? Straightforward question. So I'm expecting more answers here. Option A hash, B percent symbol, C dollar, D star. Which character is used to identify the fields or columns? Kritika, thank you. Do you want to rethink your answer? Okay. One, two, three, four, five, six. Glad, happy, thank you. So C is the right answer. Question 8. In awk, which command is used to get the CA coordinates from a PDB file? Option A, awk, then quotes $1 tilde atom and operator. I'm not going to read this out. Just look into the options A, B, C, and D and choose one. Thank you, Devangana. Thank you, Kritika. And as you all pointed out, Malini also. 4 votes for option A, which is right. Oh, I had a snippet for this. Probably it's there here. Oh, maybe this question is there in your current assignment as well. I'm not sure. Then this is a repeat question. I'm sorry about that, but I think we have some more questions in the end. So that should work. Question 9. What is the minimum number of layers required in neural network? Option A 1, B 2, C 3, and D 4. Thank you, Nagamani. That's one vote for C. Thank you, Kritika. Others? Thank you, Devamana and Amardeep. That's right. So you need at least 3 layers for a neural network. So it can be more depending on the complexity. You can have multiple hidden layers between input and output. So minimum is 3. Question 10. Which of the following is a real value prediction in bioinformatics? A. Predicting slow and fast folding proteins. Predicting disease causing and neutral mutations. Sorry. C. Predicting the binding affinity of protein-protein complexes. And prediction of stability and stabilizing and destabilizing mutants. Think about this. Which of the following is a real value prediction? Thank you, Rohini and Nagamani. Others? Okay, Malini goes with C. It's alright to be wrong. You can, shoot in the dark, blindly attempt, just guess. Okay. What about A and B? No takers. Alright. So, whenever you see such questions, look into options that are classification problems. Predicting slow and fast folding proteins. So you're classifying the the proteins into slow or fast folding, right? Option B, predicting disease causing and neutral mutation. So you're looking into mutations and splitting them into disease causing or neutral, right? Predicting the binding affinity of protein protein complexes. Now, you're not classifying these protein protein complexes as more affinity or less affinity or anything, but you're actually calculating the binding affinity or predicting the binding affinity of a protein protein complex or such complexes. Option B, prediction of stabilizing and destabilizing mutants. Although the degree of stabilizing or destabilizing might differ, again, you are classifying mutants into stabilizing or destabilizing. So the only option which is a real value prediction is C, according to my understanding or what I favor. I hope this is agreeable or not objectionable. So with that, we'll go into the current assignment. AUC for a random ROC curve is, okay, three answers. Great. So an ROC curve can be like this, this at varying degrees, right? My curves are bad. Maybe I should draw like this. Alright. So the one that is random will be in the middle here somewhere, where it is zero point 0.5. Area under the curve will be half of the entire. I mean, given the options, it can't be 0, not 1, not 0.75. So you have to go with 5, which is more or less reasonable for for a random ROC, that is, right. Question 12. For classification problems, which of the following is the best measure for evaluating the performance? Is it A. Accuracy, B. Pearson's correlation, C. Sensitivity and specificity, and D. All of the above? Oh, I've gotten three answers from Rohini, Nagamani, and Amarti. Any other options? Okay. So for classification problems, we saw several examples during the lecture where accuracy cannot give you the entire picture. Although accuracy can be calculated as a combination of sensitivity and specificity, where you're just putting everything together and taking a common average, sort of, right? You would have TP plus TN divided by TP plus TN plus FP plus FN, right? But it does not tell you what is the specificity and sensitivity. So sensitivity is about how sensitive your prediction is for something that's actually true, and specificity is how well you're able to sense something without being wrong, right? Or sensitivity is all about being right, while specificity is all about not being wrong. Sensitivity is more like being able to sense something is right. So accuracy, when you combine both together, it, although is right, will not give you the actual picture which is hiding behind the accuracy value. One might contribute more and the other might contribute less. So there has to be a balance between both sensitivity as well as specificity. A testing kit or a prediction tool should be sensitive, should predict something right, but at the same time should be as good as not predicting something that is wrong. I think I missed that up. It should reduce the false positives and false negatives, right? So Pearson's correlation coefficient, on the other hand, tells you whether something is positively correlated or negatively correlated. Although it's a good tool used in a lot of situations, when you're talking about a best measure for evaluating the performance of a classification problem, Pearson's coefficient, correlation coefficient, is not going to really help you. That is when one parameter is closely correlated to some feature of a biomolecule or a protein, say, or some other behavior, and you're trying to use that correlation to apply to other unknown proteins or unknown factors, unknown cases, then it might help, but not in a classification problem. So that is why we are rejecting all the other three options and going with sensitivity and specificity. Oh, so this is where I had wrongly pasted the question, the answer. I'm sorry. Question 13. If a file has three columns of data, then the command awk print $6 file name will result in option A error, option B blank output, C garbled or nonsensed output, C last column as output. Otherwise is B. Thank you, Divangana. And Amardeep. So we're all clear, right? So when you have just three columns of data, you can definitely not print something that's not available in the sixth field, right? So the only expected output is a blank output. That's right. Question 14. ROC stands for receiver operator characteristic. Option B reliability of the curve. Option C response operator characteristic. Option D response operator curve. I'm seeing a lot of A's come in. Did Amardeep say B? Oh, he has changed it to A. Alright. Again, it's a straightforward question where ROC stands for receiver operator characteristic. Nothing to explain there. Question 15. For the following assignment, where B is positive, same question, different data. What is the sensitivity? So previously we had done specificity. So in this question, what is the sensitivity? Always good to write down the four things. I think Devangana has already answered. Others, in case you have not taken the assignment, you can always do it now and answer the question. Two more B's. So as a practice, I would ask you all to find out how many points of data you have. I think it's the same 16, 6, 7, 8, 9, 10, 11, 12. So this will eliminate the errors that you make, right? Last time some of you got 50, 57, you chose the option that was closest. But instead, if you first, you know, uh, figure out how many data you have, then it'll be easier. I think I'm doing it a little spooky. Okay. Kritika has also answered. So, four B's, is it? Okay. Four B's. Let me just quickly solve. So two positives, one, two, three, four, five, six. Two negatives, one, two, three, four, five. False negatives. So predictions are negative, but experiments are positive. One, that's it. False positive, one, two, three. Oh, there's one more here. So this is two, and I have three. Is that right? So first check this. 6 plus 5, 11, plus 5, 16. So I have accounted for all the fellows, right? Now the question is sensitivity. Was the previous question also for sensitivity? I forget. Or was it specificity? I don't remember. So you have true positives by all positives, which will include false negatives. Am I right? Yes. So TP is 6 divided by 6 plus false negative is 2, which is 6 by 8, 3 by 4.75, 75%. So I side with you all. The answer is B. Great. Question 16. Which of the following equations is correct if the correlation between two sets of data A and B is -1? Okay. How many B's? Nagamani and Rohini say B. I still don't know what this means. Is it 2B or B square? Maybe it was B square in the assignment and I copied it like this. Hmm. This is a case of positively correlated story. So only option B gives you a negative correlation of -1, right? And, and you can see that for every decrease, when A increases, B decreases. Only then you will have a correlation, right? So option B is your right answer. Maybe I can include something for this question too while I upload the PPT, since I see that the answering is very low for this. Question 17. The specificity of the following confusion matrix is. What is specificity again? The negatives, right? True negatives plus false positives. Are you sure, Rohini? Specificity is true negatives by true negatives plus false positive. Okay. So positive, actual and positive predicted will be true positive. Predicted and actual negatives will be true negatives. So I like to eliminate those two first. And then predicted negative, actual positive will be false negative. Predicted positive, but actual negative will be false positive. Am I right? So total negative, I'm sorry, true negatives will be 20 divided by, so I'm getting 0.8, and I was just reading out the answers, plus false positive is 5, it's 20 by 25 or 4 by 5, which is 8 5s are 40. Now why did Nagamani get 83? Did you do 12 or something? I don't know, 5 by, is that, are you okay with the answer, Nagamani? Did you get, how did you do the calculation? 12 by 24, is it? Okay, I think, Rohini, I think you mean specificity is true negatives by true negatives plus false negatives. But that's not the case because it's false positive here. Or am I making a mistake? Specificity is true negative by true negative plus false positive. This is truly positive, truly negative, and false positive. Okay. Oh, I've made a mistake in this. Alright, guys, if you're following, wait. Okay, so the lecture is predicted here and experimental here, and then it was given TP, FN, FP, and TN. So this is what you followed and did the calculation, right? Huh. Now look into these guys. I was definitely not. I have written this in my notes. That's why I'm able to even understand your query now. Otherwise, I would have been stuck. I mean, Kritika, good that the answer is between 0.75 and 0.85, so it's fine. You guys got through. That's great. But don't do this mistake in exam. Look into the axis that is provided to you. It's the exact opposite, right? It's flipped here. So you have actual here and predicted here. Don't go blindly by TPF and FPT and no. Now I'm confused now. This is right, correct? Am I right first? When you have a prediction as positive but the experimental being negative, it's a false positive. The prediction is negative and the experiment is positive, it is false negative. Correct? So if I go by this, nomenclature which we have been following throughout this session at least. Then should be 20 by 20 plus 5, which is zero point 0.8. Yes. So we don't have any discrepancies in formula. So we are all agreeing that it is Tn by Tn plus Fp. But it's the error in Fp and Fn. Okay. Thank you, Kritika. Yeah. So the range is between this, but generally when they give you some range like this, it will be in the average. Okay. So yes, be very attentive to what the axis is and write down which is TPA and which is Fn before you jump into answers. Okay. So this is for question 18 as well as 19 common question. In a protein DNA complex with 100 amino acid residues plus I'm solving right now with you guys. So it is quite possible that I make mistakes. So if I'm making mistakes, please let me know. In a protein DNA complex with 100 amino acid residues, 15 residues are binding sites. A prediction program identified 20 binding site residues and 9 are matching with experimental data. So experimental binding site residues are considered as positives. True positives and false positives are dash and dash respectively. So we have 100 amino acid residues. I'm going to wait for answers. Meanwhile, I'm writing down what's given. Okay. Okay. Others? Thank you, Rohini. Change the color because so these are the total amino acids which are 100. So 15 residues are binding sites. So let us take that this is experimental. Okay. Experimental identified positives are 15. And a prediction program identifies 20. Thank you, Amardeep. As positives. Okay. So out of these 15, 9 are matching with experimental. So wherever there is B in experimental, there is B in prediction also in 9 sites. So true positives are 9. So that much we can infer. So in other 11 places in predicted uh, residues, you either have false positives or false negatives, or true negatives also. You never know. It can't be true negatives because 15 are all B's here. So the rest 11 is split between false positive and false negative. Okay. And 80 are true negatives. Correct? So it's 20 are predicted as positives. These are B's. The rest will be N's and the rest here are N. True negative will be 80 in my opinion. But since all of these are B's and you have 11 N's where the other end is B, wait. So 15 minus N would be 6, right? So in 6 cases you have B on top. I think I should have thought about this question before the class. My bad. So amongst these 9 are matching. Okay. So the other 20 could be anywhere. Okay, so the false positives will be 11 because you have B where it is not B in this case, so that will be 11, and false negatives will be 91. Oh, that covers 100, so there are no false negatives, is it? Weird. I mean, I get the logic, but so this absolutely excludes negatives. Of course, there's no confusion with 9 being the true positive. So in all other places I have B negative. Alright, so let me know if I should explain this question again for people who are confused. Otherwise, we can move ahead. S is for explain or move. Okay, alright. So let's do this. It's mostly because I did a very bad diagram and people are confused. And those who are clear, great. And you have 15 residues that are uh, actually experimentally found to be binding site. So this 15 can be actually anywhere. I just drew short lines that confused maybe people 1, 2, 3, 4, 8, 10, 11, 12, 13, 14, 15. Okay, so these are experimentally found binding sites, and then you have predicted, and they are predicting 20 different sites. So first let me just map some random 9 sites. 3, 4, 3, 6, 9. Okay, so in other cases I have n, Maybe I'll change the color, sorry. And I apologize for confusing the clear people who were clear until now and got confused because of me. Uh, for a contrasting color, I'm going to go with N, 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 N. Okay, in all the places it is probably N throughout. Okay, but let's not worry about. So I'm not going to count the other areas, but I'm just going to. There's my pen. Yeah, N throughout. Okay, goes on. So if you look at the question, in a protein DNA complex with 100 amino acid residues, 15 are binding sites. So when you say 15 are binding sites, this is experimental, which matches with our map. And the second is a predicted program identifies 20 binding sites, which are again Bs. And these 15 are also Bs. When you have 20 here, so when you count, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Apart from these, where you have n in experimental, in certain cases you have b in prediction. That is how you get 5 extra. Right now it is 15, right? But let's say you have n here and b, n here and another b, n here and b3, 4, 5. Oh yeah, I've completed 5. So in total it has 20 bees, right? So I will have to put some more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This is a very bad because it's not up to scale. Okay, so you have a lot of intervening spaces where you have just ends. Okay, so amongst these guys you have 20 B's here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oh, I hope there is only 4, 5, 10, 15. Let me put another 20. So you have 20 B's according to prediction, 15 B's according to experimental, and 9 of them thankfully match. What are those 9? 1, and then you have 3, 6, 7, 8, 9. So your true positives will be 9, true negatives will be, I don't know, god knows. Of course you can calculate from here. False positives and false negatives. So when is it false positive? When you have a prediction that says it is B, but you have uh, N on the other side. So all the green B's here are false positives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It should be 11, but I've done some mistake in the addition. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21. So first I had a right number and then I put one extra. So if you have 20 B's and 9 of them match, you will have 11 which are B's but they are matching with N. So it is 11. I hope this was clear for Kritika. So in prediction, you have 20 B's, of which 9 are matching with the experimentally found B's, which leaves 11 as B's which are not actually B's. Therefore, these are false. positives. Yeah, and it was a very straightforward question which I complicated unnecessarily. So false negative will be when you have a negative, but it is actually positive, which can be true because there are cases where you have six more B's in experimental which are not matching with uh, predicted values. So you might have six there, probably. I'm sorry, six here, and the rest will fall into true negatives. So even this might come up as a question where you are asked to find the other. Uh, these are straightforward, right? Or ideally, if I had not confused people here, it would have been straightforward. So you will have 84 or something as true negatives. If my math is right, or it should be 74. This is 20, yeah, 74. All right. So I hope we are clear until here. Question 20, for the data given in question 18 and 19, the sensitivity of the method is, again, what is sensitivity? True positives by true positives plus false negatives. Oh, so it did help that we found false negatives. 6. What is true positive? 9 by 9 plus 6. Right? 9, 5, 3, so 15. Yeah, that should be 9, 6, 60%. Yeah, thankfully. Alright, so if everybody gets that answer, we can move forward. Question 21, what is the command to write the lines which have the value of more than 57 in fifth field? Thank you, Amardeep and Nagamani. No, if you understand the logic behind command lines, that should help you get through the exam. Is that right? Because I really messed up explaining the previous question. I hope I didn't confuse the hell out of people. So out of 100, experimental positive was 15, predicted positive was 20, true positives were 9. So that directly gives us false negatives are 6 and false positives are 11. Right? And so if you sum up these stuff, you will get true negatives equal to 80 equals 70. Right? Is that right? False negative 6. Yeah. So maybe you can remember this this probably you guys have already figured it out, but since I just saw the question, I got a little thrown off, confused. Yeah, option A is right. Any other answers? So have the value of. Always look for the syntax awk with quotes where you might have a condition and then the command to print. So command to write the lines which have the value of more than 57. So it has to be greater than, not greater than, and equal to. And when they say fifth field, if you have an option that says 6, again you can reject the option. Definitely it's not none of the above. So it definitely obviously is option A, right? And as far as I saw, I mean, I'm seeing in these assignment questions, the awk commands are quite simple only. So go over all the examples that have been discussed in the lecture and get the logic of how it is being framed. Then you should be okay for the exam. So no need to worry so much. I've also attached some tables that were shown in the lecture. I've just snipped those and put it here so that it's easy for you for a ready reference, the symbols, operators, and what they mean and stuff. This is for some more questions. Question 22. The command to print columns 6 and 4 from file data 1 to result 1. So understand this as to another file which is result 1. Option A, awk, and ignore the gaps in the previous question also. Rohini says 1A. Madam says B. Others? Mardeep also agrees with B. Rohini, do you want to rethink your option? As far as printing column 6 and 4 goes, both options are right. But you want to print columns from one file to another file. You're writing into a separate file. So which operator should be used? So this does not tell anything between these two files, right? You generally use this greater than symbol or operator to say that you want to write it into a separate file named result1. Correct? It's not column 5 or 3. So otherwise, the operator wise it's right. But the columns picked are wrong. And I don't see any difference between C and D, except for, of course, okay. So this is the error probably. It has to be in smaller case, right? I thought it was a typo. So everybody cool with this? Moving on to question 23. Which of the following is a real value prediction? So use the hint that I gave you before in bioinformatics. Option A, prediction of slow and fast folding proteins, prediction of folding rates of proteins, prediction of high and low affinity protein-protein complexes, prediction of stabilizing and destabilizing mutants. Very similar question. Don't fall for fake options or confusing options. Think about which questions are classification based and which questions require a real value prediction. Nagamani says B. Take a random guess. There's nothing wrong. We are just going to learn what the right option is. Lamina and Rohini go with C. Others, look into these options. Once again, prediction of slow and fast folding proteins. So you're classifying the proteins into slow folding and fast folding. How do you know that? Because you're setting some limit. So above this I will call them fast, below this I'll call slow, or less than or equal to, greater than or equal to, right? Similarly, prediction of folding rates of proteins, you are not quantifying or qualifying this as low or fast or high or low. So this is a case for real value prediction. When you see C, prediction of high and low affinity. Although affinity of protein complexes was the answer previous time, maybe I can show you the option. So see here you're not talking about high and low affinity complexes. Definitely a protein can have a higher affinity, certain protein complexes can have a higher affinity, certain complexes can have lower affinity, or protein ligand complex can have greater affinity or lesser affinity. But here you are not talking about or classifying them into a high or low or less or more. It's about predicting the binding affinity, the parameter itself, the property itself of a protein complex. Again, slow and fast was considered a classification problem. Here also, disease causing a neutral mutation could be of varying degrees, but you're classifying them. Similarly, stabilizing and destabilizing mutants, you're having a threshold that separates one from the other. Right, so is the case with this question, where you have stabilizing and destabilizing mutants, where you are not worrying about by what degree, but simply to classify them into two groups. And affinity of protein complexes, although you can still calculate, here it is about classifying them into predicting the prediction into a high and low affinity complex. So the right option for this case, as Nagamani rightly pointed out, is B. Cool. Whenever you have this and that, this or this, stabilizing, destabilizing, it's a classification problem. Look for the option where you have only the parameter or property of something being calculated without any classification or without any threshold that separates it into two separate categories. Last question for sensitivity calculation. Which are the following? I mean, for the following assignment, what is the sensitivity? Sensitivity is true positives by false negatives. So I can just go for what is true positives. Answers. I mean, I've literally written down everything. So are you all getting the same? I guess you are bored of doing this type of question. Is everybody getting the same thing? I'm waiting for a response. Or is it my problem with my net? Can I proceed? Are you all getting the same answer? Shall I take that as a S and proceed? For the following assignment, okay, that's the same question. ROC is a trade off between Option A, sensitivity and 1 minus sensitivity, specificity. Option B, sensitivity and specificity. C, sensitivity and accuracy. D, accuracy and 1 minus sensitivity. Are you all there? And was the previous question okay? Guys, let me know if there is an issue with audio, video, internet connectivity, something. Okay, at least I know you guys are there now. Okay, Nagamani says B. Two options, two votes for B. Think about what is the plot for receiver operating characteristic or ROC. What's on the x-axis and what's on the y-axis? So ROC is a curve between FPR and sensitivity, right? True positive rate and false positive rate. So this will be TB by TB plus FN. And what is FPR? 1 minus specificity. Yes or no? What is specificity? True negative by true negative plus false positive. So when you do 1 minus that, what will it be? If I take LCM, true negative plus false positive minus true negative divided by true negative plus false positive, right? That will cancel these two, which is my false positive rate, correct? And for sensitivity is otherwise known as true positive rate. That's why they say ROC is a plot between TPR and FPR, which is equivalent to sensitivity and 1 minus specificity. So to answer your question now, what will be the answer? ROC is a trade-off between the sensitivity and 1 minus specificity, sensitivity, specificity, sensitivity, accuracy, or accuracy and 1 minus sensitivity. I have given you the answer right in the slide. I hope I'm audible and this live relay is fine, right? Yes, thanks a lot. So can we all agree on option A? Yes, ROC is a trade-off between sensitivity and 1 minus specificity because it's plot between TPR and FPR. Okay, this is simplest and last question of the day. In printf, which letter is used to format strings? Is it F? Option B S? Option C D? Option D A? Thank you, Nagamani. Others? Thank you, Kritika. Thank you, Darshana. So we're all clear with this question, right? So with this, my questions end. In case you want me to repeat or do some of these questions or address something else, I can do. So I just pasted a few slides for ready reference. These are from the lectures only, nothing new. So you know D is for decimal, F is for floating point, S is for string. Thank you, Usman. And again, what symbols are used for what? So you can share this, use this. So okay. Question 18 and 19 are actually very simple. I would like to do this the simpler way now and not confuse people. Let's look into the question again. In a protein DNA complex with 100 amino acid residues, 15 are binding sites. Okay. What we did visibly, I think a lot of people got confused with what I did here. So let's look into a simpler way of doing things. You have the total amino acids as 100 and 15 residues are binding sites. When you say 15 are binding sites, they mean experimental positives or experimental B's are 15. Okay. Next line, a prediction program identified 20 binding sites. And they say when they do not mention anything, you can take it as experimental. When predicted, they will explicitly say in this question. Need not necessarily be the same case for everything. Generally, when they just uh, go with R and leave something, it means that experimental binding site residues are considered as positive. which means these are the real B's and you're comparing it with the predicted positives. B's are 20. Now with this information, what can you find? Last line helps where they say uh, 9 are matching with experimental data. So wherever there is a B in prediction, there is a B in experimental too in 9 such places, which means true positives are 9. Until here, are we clear? True positives are where you have B and B in both. True negatives are cases where you have N and N in both. And then you have false positive and false negative. So I want you to remember that experimental positives or P's minus true positive will give you false negative. Predicted B's minus true positive will give you false positive. I'm giving this out as an expression. When you think about it, wherever you have B's in experiment, subtract it with true positives where there are matching B's in both cases. Maybe I can use this diagram. You have B's matching in all places in 9 cases, and in cases where there are uh, how do I put n in place of b, where you have b in experimental case and n in prediction case, these are your false negatives because you have n in prediction and b in experiment. So this is false and it is negative. So these are false negatives. When you have n in experimental and b in prediction, these are false but positive, right? So you have 20 B's in prediction and 15 B's in experimental, of which 9 are matching, which means there are 6 cases in total where there is B in experimental and N in prediction, which will give rise to false negative. So experimental B's are 15 minus true positives are 9, which gives me 6. Second case, predicted B's are 20 and true positives are 9. And in other 11 cases, I have B in case of prediction, which is this, but N in case of experimental value. Therefore, it is a false positive. And how can I get this? 20 minus 9 is equal to 11, right? Maybe I should write the expression. I'm going to write it as 20 minus 9 is equal to 11. Now, how do you find true negatives? Just add everything, you should get 100. So, 9 plus x plus 11 plus 6 is equal to 100. So 9 plus 11 will be 20 already, plus 6 is 26, x is equal to 100 minus 26, which gives you 74. I hope that's right. Yeah. So this is 74. Until now, are you clear, Darshana? Others also who got confused previously can respond. Now they're asking question: true positive and false negatives are A and B respectively. So TP is A and FP is B. So from here TP is 9 and False positives are 11. Clear? Moving on for question 20, they're asking what is the sensitivity of this method where you have TP by TP plus Fn. So you know it is 9 by 9 plus false negatives where 6. False positive was question B. Question C, this third parameter that you are finding here is false negative. So you can arrive at 60%. I hope that was better now than previously. You can also look into this visual clumsiness that I've done here, but I don't know how far. I think I can't erase this thing. Anyway, if there's anything else, you guys can tell me. Otherwise, I can close down the session. If any other question needs to be repeated and such. Thank you, Darshana. Yes, Pratika, I think I've already entered this. I'll respond within a day or two, generally the same day, but it might take a few hours, not immediately. It depends on when I actually see the mail, but you can always reach out to me. So if I know, I'll help you out. Is that all? Okay. Thank you all for attending today's session. I hope this was useful to you. So, looking forward to seeing you all in the next last final week of live interaction sessions. All right. So, I'm going to close this call. Okay. Enjoy the weekend. Bye.